Hi everybody, just want to make a video for Excel. I've got videos for doing this in Google Sheets and for the Numbers program, which is in the Mac spreadsheet software program. So the tricky part I guess students are having is just with sorting the data, using those random numbers to sort the data randomly. So if you follow the steps on here, at one point they're going to ask you to put random numbers over here like I have in column E. So I'm going to type equals rand, and I think you need those parentheses there, and open and close parentheses, and if you hit enter or arrow away, it comes up with a random number. And if you check it out, every time you change something in Excel, it'll automatically change that to a random number, but we don't need that feature. Okay, so get your random number, type equals rand, and then click and drag that bottom box to copy that formula to every other cell in column E. Oops. And the point of this is that we want to grab precipitation numbers randomly. We don't want to just take the first 30 numbers in January because they could be connected. Those aren't independent of one another. In statistics, this idea of independence is important so that we can draw some valid conclusions. We need to make sure our data values aren't just being picked, one after another, because maybe you'll find that, your medicine works more effectively on one day than the other day, and you will miss that because your data wasn't random. There's a lot of reasons why we need to randomize our data, but we got random numbers next to our data. So now what we need to do is sort our data set according to those random numbers. It doesn't matter if it's least to greatest or vice versa, okay? But if you click the column E, let's see, the sort button on Excel. I don't use Excel as much. I use Google Sheets a lot, but I can find it here. Maybe data. Okay, so if you click data, sort and filter, then you can click A to Z, that's least to greatest. When it asks you if you want to expand your selection, go ahead and leave that selected, and click sort. And now your data set just got randomly sorted according to these numbers. Now, it doesn't look like it's least to greatest because look, 0.52 and 0.39, then it goes back up. But that's because, like I showed you at the beginning, those random numbers just keep getting randomly generated every time something new happens in Excel. So for this first part, you need the first 30 numbers. So I'm going to click the first one, and then I'm going to hold Shift and go down to 31. That way it makes a total of 30 numbers. I'm going to hold Control and press C on my keyboard, and then Control V will paste it wherever I click. Or you could right-click, copy, right-click, paste. But those are the first 30 numbers I need for my data set. And now you're ready to answer A, B, C, and D for part 1. So to answer that, you could just, if you have trouble making those graphs that it's requiring, you could just go to Google and just type in histogram generator. I can't spell when I'm talking, I guess. Let's check out the first one. Yeah, this one's good. I've used this one before. There's a place to put your data. So over here, I'm going to hold Shift and collect all my data, copy it using my keyboard shortcut, and then paste it. And then generate, and there's your histogram. Make sure with your histogram you have at least 5 or 6 bins. So down here I'm going to change classes to 6. Okay, and that helps us be more assured of what the distribution looks like. If it's just 3 bins, it doesn't really tell the whole tale. There's not a lot of space to show fluctuation in the data. Okay, so you could right click and copy that, but a lot of you guys are better with computers than I am, so you probably know what to do there. Go ahead and use online generators if you want. I don't care how they get generated, just want us to be looking at the data set so we can understand what's happening. It's non-normal, right? Very skewed. Precipitation data is usually very skewed because there's lots of days with no precipitation. For the second part, you can highlight all these little formulas, right-click, choose copy. I hope this works. And then over here, I'm just going to paste it into H. So I'm going to right click. Lots of options. I don't know. Let's try this one. Oh, shoot. It's doing the same thing as in Google Sheets. Okay, so unfortunately, you can't copy and paste this over. There actually might be a way if you play around with the options, but I ran into the same problem with Google Sheets. You just have to copy each line over here and then paste it. There's other ways of doing this. I didn't want to get too in-depth with Excel. But if you look it up, there's ways of doing this so that you can just click and drag if you type in the right formula, but we're not going to do that in this class because it's not an Excel class, it's a stats class. Oh, come on. You can probably hear my kids playing Fortnite in the background. They have an at-home day today. But the whole point of this is, look, it's, did I mess that one up? It's a sum of all the numbers from cell D211 to cell D240. It's adding up all those numbers, and then it's dividing by 30. So if you add up all the numbers and divide by the number of numbers, that's the mean, right? So this new column in column H that I'm making is a column of means. And the point is that the mean is a normally distributed distributed variable. Did I mess anything up? No, we're going to do it. The mean is normally distributed with an appropriate sample size. So it won't be perfect when we look at this histogram, but you'll see it looks a lot better. Even though our original data set, these numbers, the precipitation numbers we just saw, are definitely not normally distributed, right? The mean of these numbers, if you take a bunch of means like I did here, create new histogram, see what happens. I think with this online calculator that we're using, you have to cut off some of the decimals. It's not super powerful, it's just using JavaScript. So, okay, that's enough. But if you graph it, it looks closer to a bell-shaped curve, right? So the problem here, the reason why it doesn't look more like a bell-shaped curve is probably because it didn't have enough sample size. It's just a sample size of 30 for each of these. So probably since the data is so skewed, the underlying data, the precipitation data, first histogram, that's so skewed, we probably would want like 100 samples, and then we'd start seeing that normal distribution. But that's the big idea of this project. I hope that helps. Message me if you're still stuck, though.